I have never been so stressed grading an FRQ until today. Because these questions were not that hard. Now, the only hard one that I would say would probably be part B, because most of us didn't get that one. But part A, you should know how to take a second derivative. Part C, you should know how to justify whether we have a relative min-max or neither. And then part D was just what we did during our remote learning days. Now, your derivative here needs to be in terms of x and y. This right here is enough for 1 point. Now, it's asking you about concavity of all solutions. Yes, we know that this right here, the concavity for the solution curves will always be concave up because the second derivative is positive. Yes, but you did not tell me why the second derivative is positive. They gave us that it's in quadrant 2. Well, if we're in quadrant 2, then x is less than 0 and y is greater than 0. Therefore, the second derivative is always positive. Therefore, the concavity of all solution curves is concave up. You needed to tell me how did you know that the second derivative was positive, and that was essentially giving me what quadrant 2 looked like, aka x is less than 0 and y is greater than 0. Now, find the values of the constants m and b for which y is equal to mx plus b is the solution to the differential equation. Well, if I take the derivative of this, that's just m. Now, if that's m, I'm going to have to set that equal to this derivative right here. So now I have m is equal to 3x minus y over 2. But also remember that y is mx plus b. So now I have m is equal to 3x minus mx plus b all over 2. I'm going to simplify this a little bit. Okay. Now, see how on the left side we have an m. Okay. And then see how here we have an m, but it's with x. So here's what we're going to do. We are going to actually, no. I'm going to factor out an x here. Okay. Ignore that. Now, notice how your m is a constant. M is a number, which means that m needs to be equal to b over 2, negative b over 2, because it's a number. Notice how on the left side that there's no x on the left side, meaning that this right here, this coefficient needs to be a 0. Which means that m has to be 6. Now, if m is 6, and that's a constant, and this is also a constant, now I have 6 is equal to negative b over 2, which means that b is negative 12. So m is 6, b is negative 12. Now, for part C, you're not using the second derivative test just yet because you need to figure out the first derivative and if that's 0 or not. So a couple of you guys are giving me that the first derivative is negative 3 over 2, and then you're thinking, okay, that's negative, so we are concaving down, which means that we have a relative maximum. No, that's not how that works. You want to make sure, in order for you to use the second derivative test, that your first derivative is equal to 0. Now, plot twist. Make sure that you're also using notation here. Whenever you're doing 0 and 3, you're going to do 3 times 0 minus 3 over 2, which is negative 3 over 2, which is not 0. Therefore, f has neither a relative min nor max, because the derivative is not 0. Now, if the derivative is 0, then we could use the second derivative test and see whether we're concaving up or concaving down. And then D is just an Euler's method. We should be pretty comfortable with that, since that should be fresh in our brain. 0, 3, our derivative we saw earlier from part C was negative 3 over 2. So that meant y minus 3, and negative 3 over 2, x minus 0. We have two subsizes, so we are going to plug in 1/2. So negative 3 halves, 1/2 plus 3, negative 3/4 plus 3, which then gives us 9/4. Then if I were to plug in that into my derivative, I'm going to get 3/2 minus 3/8, which then becomes, let's see, that's an 8. No, wait. Just kidding. That's 9 over 4. So 9 over 4 divided by 2 is 9 over 8. So this is actually a 9. But this becomes 12. So 3/8. So then your new tangent line equation is y minus 9/4, 3/8, x minus 1/2. And then to approximate 1, that's just 3/8, 1/2, plus 9 over 4. Did you have to simplify that? No. Now, if you did, you should have gotten 39 over 16. If you simplified it and it was an incorrect simplification, then you didn't earn the answer point.